So here is another question on projectile motion with horizontal projection. So it is given that a projectile is fired horizontally with a velocity of 98 meter per second from the top of a hill 490 meters high. Find the distance of the target or the projectile from the hill, that is the base of the hill, and the angle with which the projectile hits the ground. Okay, so we have to find that. So first let us draw the whole situation so that we understand it in a better way. So we have the top of a hill, okay, which is 490 meters. A person standing on the top throws an object, that is whatever it is, a ball or stone, whatever it is thrown horizontally with a initial velocity of 98 meter per second. Okay, so this is the ground. So the projectile, it undergoes parabolic motion, trajectory, and let's say it strikes here. Okay, the projectile, it strikes here. So it has been asked to find the distance of the projectile from the point of impact to the hill, the base of the hill. So basically it is asking us to calculate the horizontal range, this horizontal range. Okay, and the angle with which the projectile strikes the ground. Suppose here the projectile, the point of impact is here. So the projectile final velocity will be something like this, okay, like this. It will have a horizontal component which will remain constant throughout, okay, here, okay, and a vertical component. So this is the horizontal, this is the vertical. So this angle we are asked to calculate. This is the net velocity. So these are the parameters. Now let us try to solve it. So here first let us assign the parameters. Here this horizontal velocity which is given here, this is the initial horizontal component ux. Okay, there is no component along the vertical direction, so uy is 0 meter per second. This height of the hill, it is the net vertical displacement of the projectile during its entire trajectory. Then we have acceleration due to gravity. Nothing has been mentioned, so acceleration due to gravity will be 9.8 meter per second square. Okay, and it is acting downwards in the vertical direction, so it is ay, which is equal to plus g. Again, the whole motion of the projectile, okay, it can be divided into two parts. First the horizontal part and then the vertical part. Now the acceleration due to gravity is acting in the downward direction, and for the vertical part of the projectile motion, it is downwards. So it is supporting, gravity is supporting the downward motion of the projectile. So that's why it is plus g. Okay, so now first we have to determine the distance of the target from the hill. So here we have to calculate the time of flight, okay, the entire duration for which the projectile was in the air. So you can determine it through the derivation, that is s is equal to ut plus half at square You can write it for the y-axis, that is Sy is equal to uyt plus half ayt square. This will become 0 because uy is 0. So t will be simply equal to 2 Sy by ay. Okay, Sy is the height of the hill, ay is equal to plus g, so this becomes 2h by g. So if we calculate it, it is coming 2 into 490 by 9.8. So time of flight is coming around 10 seconds. Root over of 100, that's 10 seconds. This is the time of flight. Now, horizontal range is simply equals to Sx, okay, which is the net horizontal displacement. Now again, from this equation we can write Sx is equal to uxt plus half ax t square. Here if you see, like in our all discussions related to projectile motion, I have always pointed this out, that for the horizontal part of the projectile motion there is no accelerating or decelerating force. Okay, there is nothing to support the horizontal motion or oppose the horizontal motion. That's why the velocity of the projectile during the entire course of the projectile motion, the horizontal velocity is always constant, because ax is equal to 0 meter per second square. Okay, so here ax is 0, so this becomes 0, so we only have Sx is equal to uxt. We want to calculate the horizontal range, so this comes by replacing t with tf. So we have r is equal to ux tf. Ux is already given in the question, which is how much? 98 meter per second, and tf we calculated 10 second. Okay, ux is 98 meter per second, tf is equal to 10 second, so we have 98 into 10, that is equal to 980 meters. This is the horizontal range, or the distance of the point of impact from the base of the hill. This is the first part. Then we have is the second part of the question, which is the angle with which the projectile hits the ground. So here Vx is always equal to ux, it is constant, 98 meter per second. We have to calculate Vy here, so we'll be using the equation Vy is equal to uy plus ayt. Uy is 0, there is no initial vertical component, this is 0. Ay is equal to g, and we just want to calculate the vertical component of the velocity just before the projectile is striking the ground. So we'll take t as time of flight, so this becomes gtf. Okay, gtf. So this is equal to 9.8 meter per second square, which is acceleration due to gravity, and tf is equal to 10, so that is equal to 98. So Vy is also equal to 98 meter per second. Vy is also equal to 98 meter per second, which is the final velocity, final vertical component of the velocity just before the projectile hits the ground. So now we can calculate beta. Okay, here tan beta is equal to Vy by Vx. That implies beta is equal to tan inverse of Vy by Vx, which is equal to tan inverse of 98 by 98, which is equal to tan inverse of 1, which is equal to 45 degree. Beta is equal to 45 degree. Okay, so here we have calculated the horizontal range and the angle with which the projectile strikes the ground. Okay, so beta is equal to 45 degree, the angle with which the projectile strikes the ground. Okay, yes. So here is another question on projectile motion with horizontal projection. It is given that a body is thrown horizontally from the top of a tower and strikes the ground after 3 seconds at an angle of 45 degree with the horizontal. Find the height of the tower and the speed with which the body was projected. So first let us draw the whole situation. So here we have a tower. Okay, so someone projected a body, an object, horizontally from the top of a tower. Now obviously this is a case of projectile motion with horizontal projection because it has been mentioned here horizontally. So the body will undergo this kind of a trajectory and it will strike the ground here. Okay, so it is given that the total duration for which the body was in the air, that is equal to 3 seconds. So indirectly it has been given that the time of flight of the projectile, that is equal to 3 seconds. Okay, the time of flight, and the body, it struck the ground making an angle of 45 degree with the horizontal axis. That is, let's say the final velocity vector is something like this, so it will make an angle of 45 degree with the horizontal. This is the situation. We are asked to find the height of the tower. Okay, the height of the tower we have to find, and the initial velocity that we have to find, the initial projection velocity, which is also the horizontal projection velocity. So here first let us assign the parameters. Here this height of the tower, it is nothing but the net vertical displacement Sy. Always while solving projectile motion problems, always split the whole situation into horizontal and vertical components, analyze them separately. That is the number one tip while solving projectile motion questions. So height of the tower is the net vertical displacement. This initial projection velocity is the initial horizontal component of the projection velocity. There is no vertical component, so the initial vertical component will be equal to 0. This will remain constant throughout the motion. Okay, this will remain constant throughout the motion. Why? Because there is no accelerating or decelerating force in the horizontal direction. That is, Ax is equal to 0 meter per second square. Acceleration due to gravity is acting downwards. That is, Ay is equal to plus g meter per second square. That is plus 9.8 meter per second square. Why? Because the downward motion of the projectile is supported by this downward acting gravity force. That's why plus. So first let us determine the height of the tower. So we'll be using the equation of motion. Sy is equal to uyt plus half ay t square. Okay, uy is 0, we have calculated, so this whole term, it will become 0. Okay, now we will substitute for sy to calculate the height of the tower. We'll substitute ay with g and t with time of flight. This because when t is equal to time of flight, the body or the object, it will cover a net vertical displacement of the height of the tower. Here, this, when the object reaches from here to here, it undergoes a net horizontal displacement of this, the horizontal range, okay, which is Sx here, that is not asked, and the net vertical displacement of this for the entire time of flight duration, this much, which is given 3 seconds. So that is equal to 1/2 into 9.8, nothing has been mentioned, so 9.8 is the default value, into tf square, which is equal to 3 square, this. So it is coming around 44.1 meter. So the height of the tower is equal to 44.1 meters. Okay, so this is the height of the tower. Next, it has been asked to calculate the speed with which the projectile strikes the ground. So here this angle comes into play, this angle information. So we know that when a projectile undergoes this kind of a motion, the horizontal velocity, it always is constant. Vx is equal to ux, that is always constant, and it is also asked here to find this parameter. And the vertical component, this keeps on increasing as per this relationship, uy plus gyt, that is uy plus ayt, which is equal to, here uy is 0 because the initial vertical component, that is equal to 0. So this becomes g into t. Okay, so we have to find the velocity just before the object, it strikes the ground, just before. So we'll substitute t with time of flight, that is 9.8 into tf, which is equal to 9.8 into 3 seconds. So it is coming around 29.4 meter per second. Okay, Vy is equal to 29.4 meter per second just before hitting the ground. That's why we took t is equal to time of flight, this. So here, if you see, tan beta is equal to Vy by Vx, Vy by Vx. That implies tan 45 degree, it is given here, that is equal to 29.4 by Vx, which is unknown, we have to calculate it. That implies 29.4 is equal to Vx, because tan 45 degree is 1. So Vx, the horizontal component, that is equal to 29.4 meter per second just before hitting the ground. Now we know that the horizontal component, it always remains constant. Here in the beginning also I specified it, it is always constant, the horizontal component, because Ax is equal to 0. So it never increases or decreases. So Vx, which we calculated 29.4 meter per second, that is the initial projection velocity, 29.4 meter per second. Okay, that is also the initial projection velocity, that is equal to u. So the velocity with which the body was initially projected, that is equal to 29.4 meter per second. Okay, so see how we have used the different information which is given in the question. We have used it. We have used the principle of independence of motion, dividing the whole projectile motion into x and y components, then using the standard equations of motion to find out the different parameters. Okay, so this is the thing. Here we have calculated the height of the tower, which is 44.1 meter. Okay, 44.1 meter, and the initial projection velocity, which is equal to 29.4 meter per second. This. Okay, so this is the thing.